Hello, today's video is both on creating equations from sinusoidal graphs, sine and cosine, and also creating equations from word problems. I'm starting on packet page 16 in Unit 3, Topic 1, Part 2, packet. Page 16. I've highlighted in green all of the equations that result from the graphs on this page. A lot of my calculations are over to the sides as I came up with the equations. So if you need to understand where I came up with the A, B, D, and sometimes C values, please hit pause at any time and look at my calculations. But mostly you can see, as I told you before, that I always start with the center of the graph, which is the D value. And then once I find the center, I count up and down. If it's the same number of units to max and min, then I have my A or amplitude value. So I'm going to move down to show you some more of the equations for number 3 and 4 in green. My calculations over to the side, you can see my B value gotten from the period, and you can also see how I got my interval spacing on number 3. Number 5 and 6. Number 5's equation, -3 sine 1/2 x plus 3 pi over 2. If you look at the graph, you can see that it's translated 3 pi over 2 units to the left, and it's a reflected sine curve if I choose that to be my equation, and so it starts with a negative sign. Number 6 is a little hard to see. I got all the 1/3 by looking at the intervals on the y-axis, and I can see they gave me -1, and so it was 2 spaces to get to -1, and that's where I came up with -1/3 and -2/3. Page 17, you can see the equations for number 7 and number 8. I did a cosine curve on number 8 because it began at the y-axis. I had a phase shift for number 7, and you can see that it started at the max and then returned to the max, so I used a cosine curve after the phase shift. Number 9 also had a phase shift. I used a cosine curve starting at 5. It looks like I should have maybe, I'm not 100% sure of my equation on number 9. I'm looking at it and I'm not loving it. It looks to me like maybe I should have done a negative cosine curve. So maybe I should have done y equals negative. If I start at 10 and it's the minimum, I can say negative cosine and then I think pi over 15 is correct. But then I would do x minus 10, and then my midline is still at -2. I like the pink equation better. I'm not saying the green one isn't accurate, but this one looks like it's an easier equation to get. Then, of course, number 10, find your midline, calculate your B value using the period, and then the phase shift is 1 to the right if I use a, a 1 to the left if I use a cosine curve, and my amplitude is a strange calculation. It looks like it's 0.05. Maybe it's 0.5. Maybe it's 0.5. Okay, so for our word problems, I am skipping over page 18. that graph is very hard to read. And so I want to start with a word problem that's a little easier to understand, as well as a word problem that you're more familiar with, which is our beloved Ferris wheels. So we're going to make predictions using trigonometric models. So we're going to use the word problem information to create an equation, and then we're going to use that model to plug in values and find answers, either X answers or Y answers. Our Ferris wheel has a diameter of 4 feet, and I'm going to stop right there just to say anytime you have a Ferris wheel problem and they give you the diameter, you should find the radius, because if you remember from last year, that radius helps get us the amplitude. So take your diameter, you always divide by 2 to get the radius, and take that radius and let that be your amplitude value. So you can see I have 20 here. I'll get to the negative in a minute. And then it makes 1 revolution every 8 seconds. So I took my 8 seconds and I wrote it around the Ferris wheel, showing that 1 full revolution takes 8 seconds. And then basically, just as we did here on our XY graph, we are unspooling our Ferris wheel and creating a sine or cosine graph. I'm going to say right now, and I'll stress it on the next page on the bottom, you're almost always going to use a cosine curve for doing word problems. The reason that is because it's easier to find the max or min. And since a cosine curve, if it's a right side U, starts at the max, and a reflected cosine curve starts at the min, it's easiest to use a cosine curve to do these problems. The center of the wheel is 25 feet above the ground. That is going to be our D value. Again, you should remember this from last year. And then the only thing that I would say is different than what we did with either the unit circle this year or the Ferris wheel last year is you're going to get on at the ground level. You're not going to get on where we normally talked about, which is the initial ray, which is the positive side of the x-axis. So if I get on at the ground level, the Ferris wheel, the center of the Ferris wheel is 25 feet off the ground. So if the radius is 20 feet, right, in both directions from the center, then it's an extra 5 feet to get from the bottom of the Ferris wheel to the ground. That means that I am getting on at the ground at 5 feet. So my cosine curve is going to start at the minimum. I'm going to go, and halfway around, I'm going to get to the top of the Ferris wheel, which if you do 20 plus 20 plus 5 is 45 feet. And then you're going to return back down to the bottom of the Ferris wheel for 1 full rotation. So what I've highlighted in green gives you 2 pieces of information. I have the amplitude that we talked about from the radius, which is 20, so we've already done that. I have the fact that it is a reflected cosine curve, so I have the negative in my equation. I already told you to use a cosine curve, and now I'm going to find the center. Well, they already told me the center of the Ferris wheel is at 25 feet, so the center is also known as the central axis, or our midline, and our midline is our D value. So the only thing I have left to do is to calculate my B value. Remember, the equation for finding the B value is 2 pi divided by the period. The period is 8 seconds because my x-axis is going to be time and my y-axis is going to be feet. And so to do one complete rotation, to start on the ground and rotate after 8 seconds to the ground or to the bottom of the Ferris wheel just 5 feet above the ground, that's going to be 8 seconds. So I'm going to take my 2 pi and divide by 8. I'm going to reduce my fraction. My b value is pi over 4. And now I have my full equation. I would hit pause down here to write some of these things down because we're going to switch in a minute to the calculator. These are all calculator problems, so you can expect your test to be partially no calculator and also partially with a calculator. After hitting pause, you can use your calculator to predict what the height of the Ferris wheel is going to be after 5 seconds. I'm looking at my answer here, and I looked at my calculator before, and I got a value that's close to 39, but maybe I did the rounding thing too soon because I have a value that's 39 with a different decimal. But the first thing I'm going to do is I am going to plug my equation into the calculator, and one of the things I'm going to make sure of is that my mode, so you're going to hit that mode button, and you're going to make sure that your calculator is in radians. I think I told you how we don't do word problems in degrees because sometimes we're measuring temperature and you don't want to confuse degrees in terms of a sinusoidal or unit circle type measurement. You don't want to confuse that with degrees like Fahrenheit or a Celsius for temperature of a room or temperature outside or temperature of the season. So you're going to make sure that you change your mode to radian. So after you go down to radian, you're going to hit the enter button, and then you can hit quit at any time. After putting your equation that you came up with in the first part in Y1, you're going to hit your graph button. If your graph of the sinusoidal does not look like my blue graph, you're going to do two things. First, you're going to hit zoom, and you're going to hit number 7, which says zoom trig. That will give you your sinusoidal shape. I can't see it in my window now because if you look over here, it says your window should be for the x values 0 to 25 and for the y values 0 to 50. So you're going to change your x min to 0 and your y max to 25. You're going to go down to your y min, which is also going to be 0, and your y max 50. And now, since you've already told the calculator you want a trig graph, there is a very nice picture of your trig graph. Now it asks what happens after 5 seconds. You're going to use your calc menu, second trace value. Now it's asking at the bottom left of your screen, what is the time or what is the x value going to be? It's 5 seconds. And your calculator tells you when your time is 5 seconds, it says R equals. That looks like it's something we call polar measurement, but I don't have my calculator set on polar, so I don't really know why it's doing polar. But if you look at the R value says at 39.46 feet, that's where the Ferris wheel is going to be after 5 seconds. So I just wanted to move this over to the side. That's why I said I had 39.14 feet, but my calculator said 39.4 something feet. And so that's how high our Ferris wheel is after 5 seconds. As for the next part where it says, what is the first time you will be at 21 feet of height? So I'm going to go over to my first cycle of my Ferris wheel, meaning my first rotation in 8 seconds. And I want to know the first time I'm going to be at 21. So as you start from time equals 0 and go up the green curve, I should expect something here in terms of at what time I'm going to hit 21. So it looks like it's going to be between 1 and 2. Remember with these problems, you're always trying to make sure that your answer makes sense. So I'm going to switch back to my calculator, which I accidentally, here we go, which I accidentally shrunk away. So now to do 21 feet, I'm going to go back to y equals, and now under y2, I'm putting 21. Because remember, the easiest way sometimes to find a value is to do an intersection. So if I do an intersection of a horizontal line at 21 and our equation, I'll be able to find what the time or x or t value is when I hit 21. So I'm going to hit graph again. I'm going to do second second calc. I'm going to hit intersection. And remember, I want to get near that first 21. So it's going to be, based on our green graph over to the left, it's going to be a little bit below 21. So I'm just going to hit enter, enter, enter. And it says, if you can see it, it's very small. It says it happens at x equals 1.74 seconds. So I'm going to go back over to here. And I'm going to say, what's the first time you will be at 21 feet? It's going to be 1.74 seconds. Our second problem is from a table. So this is another kind of word problem. Sometimes this seems more confusing. I cannot stress enough that for me, I am always going to be, I'm having trouble moving this over to the side. Let's see. Okay, let me hit pause for a second. Sorry about that. The calculator was giving me a hard time. So when you're doing it from a table, I can't stress enough that it makes the most sense to, here we go again. It makes the most sense to do a graph. So rather than start coming up with my model, I'm going to take these points and I'm going to graph them. So January is 0. It's 20 degrees Fahrenheit at time 0. I'm going to hit the maximum. I'm going to hit that maximum in July at 68. And then I'm going to return back to the January temperature. I'm going to return to that 12 months later. So a full cycle is 12 months. So that's going to help us with our B value. So we can already calculate that. 2 pi divided by B is pi over 6. 2 pi over 12 reduces to pi over 6. In terms of my phase shift, there's not going to be a phase shift. If I start at the minimum, go to the max, and back to the minimum again, that is, again, a reflected cosine curve. It's an upside down U that starts at the minimum and ends at the minimum. That's going to be a reflected cosine curve. So if I start at time equals 0 at the minimum, my C value is 0. This kind of problem is perfect to use our amplitude and our D value or midline or central axis formula, because it's hard otherwise to find both the amplitude A value for our equation and D value for our equation. Our amplitude equation is max minus min divided by 2. That's going to be 24. So I know now in my equation the A value in front of cosine is going to be 24. And this can be gotten from your graphing cheat sheet, which I don't remember if it's page 8 or 9 or 10, something like that, has all of our graphing shortcuts. And then I also need the midline. The midline is the same values, 68 and 20, but this time rather than subtract, I'm adding, and then I am dividing by 2. I get 44. So that is my D value. I now have everything I need to complete my equation. Part B says, at what temperature would your model predict for April? So you are going to go into your calculator again, and you are going to put your equation in Y1, and then in Y2, well, I don't know, I have to check and see. Let's see, is there another part? No, it's just part B. So for this one, it says, what temperature would your model predict for April? April is the third month. Notice how I count 0, which is January, all the way through December, which is 11, because back to January is 12 again. So I determined that April is the third month. So then I'm just going to do second, trace, and then I'm going to do value. And then for the X value, I'm going to put in 3. And that's how I got 44. And I say it's confirmed by the graph because when I go here to April and I see where my point is, I can see that that's the midline, and under April it is 44, so confirmed by the graph. And then notice where my window is in terms of my X values and my Y values. Remember to use Z trig under zoom before fixing your window. Page 20, I have another table to create a graph. Actually, they give you both the table and the graph. And so I'm going to use the points to come up with my midline and my amplitude. And so I wouldn't worry about these decimals here. I really wouldn't. I would just basically, from the graph as best you can, I would use 8 and 12 and 14, and I would calculate from that. So if I look at my graph, I can see my maximum is going to be at 14, which is around 4 a.m., and my minimum is going to be around 6, which is around 10 a.m. So to calculate my midline, it's max plus min divided by 2. So I get 10 for my midline. Remember, that's the average depth. The average is your middle of the graph. That's your midline or central axis. So not only am I sketching the line where that happens, I'm understanding what they mean by average. Your average is the middle, and the middle is your midline. It says also find the amplitude and period. Same equation as D, except rather than add the 14 and 6, the max and min, you're going to subtract 14 and 6, and then divide by 2. So now I have my amplitude, and then my period is going to be 12 hours. I start at midnight, I end at noon. That's 12 hours. So that's my period. And the formula for our B value is 2 pi divided by the period. So my B value is going to be pi over 6. Putting it all together below, I'm going to do this time a right side up cosine curve, meaning our U shape from here to here. I'm going to have a phase shift because I'm going to start at 4. If I move from the y axis 4 to the right, that's t minus 4 for my phase shift. We already did our midline 10. We already did our B value pi over 6. And we already did our amplitude 4. There's no negative in front of this equation because it's a right side up U shape. Notice that I'm suggesting what the window should be once I use the zoom trig in my calculator, because the last question for this one says, although it does say a boat with 10 feet of water. So let's use the model to calculate. So it wants to know what the depth is at 9 a.m. and at 3 p.m. And so remember, since we're counting from midnight, it's 9 hours from 0 to 9 a.m. So I'm going to use my second trace value and put 9 in for x, and your calculator should tell you 6.54 feet. And then you're going to do the same thing for 3 p.m. 3 p.m. is actually 15 hours since midnight, since it's 12 hours from midnight to noon and then another 3 hours to 3 p.m. Same thing with our calculator. After the equation is in Y1, you're going to hit second trace value. This time you're going to put in 15 and you're going to get 13.46. Notice how I'm asking, does your answers make sense? So I'm going to go over to 9 and I'm going to go up till I hit the graph. I hit the graph around here. That looks to me like it's a little bit above 6. So that answer makes sense. And now I'm going to go over to 15, which is beyond noon. Here's 14. Here's 15. So if my graph continues in the same pattern, I should hit about here. 13.46 is approximately 14. So yes, my answers do make sense. Last part of this problem, a boat needs at least 10 feet of water to dock at the wharf. During what interval of time in the afternoon can it safely dock? So I took a picture of the graph and I just emphasized where I'm going to be above or either at 10 or above 10. And I can see that that's going to happen at t equals 13 to t equals 19, because I want only the part of the graph that's going to occur above that 10. So if 10 is our midline, I want this part of the graph here. This part of the graph is above 10 feet. And so that's going to start somewhere afternoon around 1 p.m. and 7 p.m. And then I just want to focus on the bottom of page 20 on constructing a sinusoidal model. It gives you the calculation for the amplitude or A value for your equation. Remember, every equation is in this form, A, and I'm going to use cosine because this is a word problem, and then B times X minus C, our phase shift, plus D. So our A value comes from max minus min divided by 2. Our vertical shift comes from max plus min divided by 2. And then we're going to do our B value for the equation, always 2 pi divided by the period. In number 3, it says choose the appropriate sinusoidal based on the behavior of time, given the phase shift C. And then notice how cosine with a positive A starts at the maximum value. But if I'm doing a word problem that starts at the minimum, like our Ferris wheel problem, that's going to have a negative in front, because for cosine that starts at max, you've got your U-shaped. For your cosine that starts at the minimum, goes to the max and back to the min, it has this shape, so it's going to have a negative in front. Your homework tonight is page 21 and 22. I hope to see you on Wednesday.